For nearly 50 years, the Boeing 737 has been a cornerstone of commercial aviation. Every day, these planes carry around 2.2 million passengers, with one taking off or landing somewhere in the world every 90 seconds. With over 10,000 aircrafts delivered, the 737 boasts an impressive safety record, experiencing only 0.23 accidents for every million flights. But in 2011, this sterling reputation faced its greatest challenge yet. Airbus unveiled its A320neo, promising airlines 15% better fuel efficiency. The market responded dramatically. 1,000 orders worth $100 billion poured in. Boeing stood at a crossroads. Boeing faced two choices: design an entirely new aircraft or modify their existing 737. A new design would take 7 years and cost $20 billion to make. Instead, they chose modification, promising airlines a crucial advantage. Pilots could transition to the new aircraft with minimal training, saving each airline $300,000 per plane. The 737 MAX moved through certification at unprecedented speed, just 297 test flights, half the number of the previous models. By 2017, the FAA granted approval, and Boeing stock reached an all-time high of $371 per share. At the heart of the 737 MAX's design lay a significant engineering challenge. The new fuel-efficient engines measured 69.4 inches in diameter, nearly 10 inches larger than the original 737s. The 737's low ground clearance meant that these engines couldn't simply be mounted in their original position. Boeing's solution was to move the engines higher and further forward on the wing. This modification created an aerodynamic issue. During certain flight conditions, the new engine position caused the aircraft's nose to pitch upwards, risking a dangerous aerodynamic stall. Their solution was MCAS, the Maneuvering Characteristic Augmentation System. When it detected a high angle of attack, MCAS would automatically adjust the horizontal stabilizer, applying up to 2.5 degrees of nose-down trim. The system could exert 300 pounds of force on the control column, more than most pilots could physically counter. The warning signs were there. Safety committees raised 17 significant concerns. Engineers calculated that if pilots took more than 10 seconds to respond to an MCAS malfunction, the consequences would be catastrophic. Furthermore, the FAA's oversight structure revealed troubling gaps. Just 45 FAA employees were tasked with overseeing Boeing's 78,000 engineers. Under the Organization Designation Authorization Program, Boeing was permitted to self-certify 96% of its own safety assessments.
October 29, 2018, Lion Air Flight 610 departs Jakarta. Within minutes of takeoff, the pilots face an unprecedented challenge. For 11 harrowing minutes, they battle their aircraft as MCAs activate 26 separate times. At 6:32 a.m. local time, the aircraft plunges into the Java Sea at 450 miles per hour. March 10, 2019. Ethiopian Airlines Flight 302 faces the same fatal scenario. Despite following Boeing's emergency procedures, the pilots lose their flight for control. 6 minutes after takeoff, the aircraft crashes at 575 miles per hour. Together, these tragedies claimed 346 lives: parents, children, humanitarian workers, and UN officials. Within 3 days, aviation authorities worldwide ground all 387 MAX aircraft, affecting a total of 59 airlines. The consequences were immediate and consequential. Airlines canceled 8,600 flights in the first week alone. Boeing faced $20 billion in direct losses, $60 billion in canceled orders, and a $2.5 billion settlement with the Justice Department. The crisis sparked intense debate within the aviation community. Industry veterans pointed to the MAX's successful return to service, with over 1 billion flight hours since recertification. They emphasized that competitive pressures in commercial aviation are real. Airlines demand fuel efficiency to survive in a market with razor-thin margins of just 1.5%. Some argued that pilot training differences between regions played a role, noting that U.S. carriers had logged 55,000 flights without incident before the grounding. Safety advocates and industry reformers saw the crisis differently. They pointed to the 71 potentially serious incidents reported by MAX pilots before the crashes. Aviation safety experts highlighted how the drive for market share had compressed the typical 7-year development cycle to just 6 months for major system changes. Pilot unions revealed that 70% of surveyed pilots felt inadequately informed about MCAs during their initial training. These debates drove fundamental changes in aviation safety. Today's MAXs feature dual sensor inputs, mandatory 20-hour simulator training for all pilots, and completely redesigned flight control software. An independent technical review board now oversees all critical safety decisions with enhanced transparency requirements that increase certification documentation by 275%. Today, the 737 MAX crisis stands as a watershed moment in aviation history. It reminds us that engineering isn't just about solving technical problems, it's about protecting human life. No market pressure, no competition, no deadline can ever justify compromising this fundamental principle. In aviation, safety isn't just a priority, it's the foundation upon which everything else must be built.